graphing in slope-intercept form. Now we've been graphing some stuff. Okay, what was the last type of equations that we graphed? Anybody remember what those called? They start with a D. Start with the letter D. Variation. Direct variation. Yeah, we graphed direct variation. Okay. So now we're going to graph in slope-intercept form, which slope-intercept form is y equals mx plus b. How many of you have at least heard of that before? At least, yeah, good. You at least ring a bell. Good. Okay. So we're going to spend 2 whole days going over this. Okay, how to graph when something's in this equation, in this form. Okay. So in this form, there are 4 different variables, right? Y, m, x, and b. Okay. The y and the x, the y, if you had to plug everything in, would be the output. Okay, or it's what it's equal to, the outcome after you substitute x, m, and b. The x we call the input. If we were to put in something for x and then have m and b, we would get something out for y. Okay. Most importantly, the 2 variables we really need to know are the m and the b. Okay. The m we know stands for the slope. Okay. This variable, so the number in front of the x stands for the slope of the line. And then the b variable, this one here, okay, stands for the y-intercept. The y-intercept. What's it mean to be a y-intercept again? Like what does that mean on the graph? Yeah, Jim.
Where the line crosses.
Right, where the line crosses the y-axis, okay? So wherever that point is, okay, it's where that line crosses the y-axis. So whatever this number is right here is where it tells us where it crosses the y-axis. Okay? So we can graph them if they're already in slope-intercept form really quickly. And the first thing we want to do is we want to find out what is the y-intercept, okay, and then plot that on the coordinate plane. Just like last time when you guys did direct variation, you knew the y-intercept was at 0, 0, so you start at 0, 0 usually, and you went up something or down something and over. Okay, here we want to look at what this number is. That's where we're going to start at the y-axis. Okay, then we use the slope. Remember, that's the m, the number in front of the x. We use that to find the other points on the line by using rise over run. Right, we go up or down a certain amount. We go left or right a certain amount. Okay, and then we draw a line through those points. We put our arrows on the end. That's how we graph these equations in slope-intercept form. Okay. All right. So, for example, if I want to graph this equation, y equals 2x minus 5. This is in slope-intercept form, right? Y equals mx plus b. Now, instead of a plus, it's a minus. You can have that. Okay, it's still in slope-intercept form. Remember, the number without the variable is the one that tells you where you start at on the y-axis. So, since it's a minus 5, I'm going to start at negative 5 on the y-axis. If it was a plus 5, I'd start at positive 5. Okay, but it's a minus 5. So I put a point there. And then I look at the slope. What number is the slope here? Well, the only other number that's left, 2. Right? The number in front of the x is the slope. Okay? Remember, the slope tells us how much we go up or down over how much we go left or right. If there's no denominator, I could just write it over 1. Okay? Because anything divided by 1 is still itself. So the top number tells me how much I go up or down. So am I going to go up or down 2? Up 2 because it's a positive 2. And am I going to go to the right or to the left 1?
Right.
To the right because it's a positive 1. So then I would put a point up 2 over 1. I could do that a couple more times. Up 2 over 1. Up 2 over 1. Okay. Once I have that, I connect those points with a line. And there's that equation graph. That's all we're doing today. Is given an equation. Okay, look at the y-intercept. Plot it. Look at the slope. Do rise over run and graph that line. If it's in slope-intercept form, it's pretty quick to do. Any questions with that one to start with? All right, let's look at another here. Y equals negative 3/4 x plus 4. Okay. Again, I'm going to look at the number without the variable is where I start out on the y-axis. So I'm going to start at positive 4 on the y-axis. 1, 2, 3, 4. There's my point. The number in front of the x tells me the slope. That's this number here. So, remember the top number is how much I rise or fall. The bottom number is how much I go left or right. But there's a negative here. So, should I go down 3 and to the right 4? Or should I go up 3 and to the left 4? Or does it matter? Doesn't matter. As long as you take the negative with one or the other. Don't take it with both because a negative over a negative is a positive. Let's say we treat the negative with the 3. That means we need to go down 3 because it's negative 3 and then to the right 4. You're right there. Down 3, to the right 4. I could do that a couple times. I could have also went up 3 and to the left 4 if I took the negative with the denominator. Should be right there. So got a few points. Connect them. Draw my arrow. There's that equation graphed. I had it slope-intercept form, did the y-intercept, looked at the slope. Any questions yet at this point? So got a couple more. Where am I going to start out on the y-axis here? Negative 8, because that's the number without the variables where I start on the y-axis. So I'm going to go down to negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And put a point. My slope, how much am I going to go up or down? Up 1, and then to the right 7. All right. Up 1, 1, 2, 3, 4, 5, 6, 7. To the right 7. Remember, that's also the same thing as going down 1 and to the left 7. If I had a negative over negative, that's the same thing as a positive. So I wanted to put another line, because if I went up 1 and over 7 again, it'd go off the graph. That's okay, but let's be more accurate. Let's go down 1 and to the left 7. 1, 2, 3, 4, 5, 6, 7. Connect those. There's that equation. Pretty straightforward, right? Not too terribly difficult. I'm looking at the y-intercept and the slope. Now, what if it's not in slope-intercept form? Like, for example, what if I told you to graph this equation? What if I told you to graph this equation? What do you think we would probably do? It's not in slope-intercept form. I don't know what the slope is looking at that. I don't know what the y-intercept is looking at that. If I just said graph this, any idea where we would start? Not a bad guess, but it's not in slope-intercept form, right? Remember, slope-intercept form says y is by itself. Then you have mx plus b. When it's in this form, it's really easy to graph. I can put this in this form if I just rearrange it, the equation, to get y by itself. If I solve this equation for y, or get y by itself, I can get it in this form. That way it's a lot easier to graph. So I want to get this y by itself. So I'm going to leave this minus 3 or this negative 3 last to undo. So I need to move this 4x to the other side of the equal sign first. Just like if it was a positive 20, how would you move it to the other side?
Minus 20?
Yeah, I would minus 20. So just like since it's a positive 4x, I'll just subtract 4x. I do that there, that goes away. That means I need to subtract 4x over there. And let's rewrite what's left. Negative 3y equals 18 minus 4x. Now, why didn't I just subtract these and write like a 14x there? Yeah. Right, exactly. You can't do that. 18 doesn't have an x with it. They're not like terms. Okay? So I just leave it like that. I've almost got y by itself. I just need to undo this multiplication by negative 3. So the opposite of multiplying by negative 3 is dividing by negative 3. So if I divide this by negative 3, that becomes just 1. That means if I divide everything on the left-hand side by negative 3, I have to divide everything on the right-hand side by negative 3. So I need to divide that by negative 3 and that by negative 3. So I'm just left with y here. I'll go ahead and simplify these if I can. 18 divided by negative 3, does that divide out to some integer? Yeah, it divides out to negative 6, right? And then negative 4 divided by negative 3. I would never write decimals when graphing, because then it's hard to tell rise over run, right? I would just leave it as a fraction. Okay? If you leave it as a fraction, you can tell how much you need to go up or down, how much you need to go left or right. But I can simplify this negative over a negative. I would still get the same answer if I left it, but since it's a negative over a negative, what's any negative number divided by any negative number is a positive number, right? So I could change that to a plus 4/3 x. Are you with me there? I just changed this negative over negative to a plus. So finally now this is in slope-intercept form. I just switched these two things around. Okay? So if you really want to, you can switch these two things around to get it to look like we did before. I could write it as y equals 4/3 x minus 6. I could just switch those around. Remember, if you switch them around, though, you got to keep the sign that's in front of the number. Now, can I graph this right here? Yeah, that's a lot easier to graph. It's in slope-intercept form. So where am I going to go at on the y-axis? -6. All right. 1, 2, 3, 4, 5, 6. And my slope, 4/3. So I go up 4 and to the right 3. 1, 2, 3, 4. 1, 2, 3. I can do that a couple more times if I wanted. 1, 2, 3, 4. 1, 2, 3. Connect that. And there's my line. So if it's not in slope-intercept form, you just need to solve it to get y by itself. Okay? You need to move the stuff around to get y by itself, put it in slope-intercept form, and then you can graph it. You can't graph it when it was just like this. You don't know what the slope is, you don't know what the y-intercept is. So one more here. If I want to graph x equals 7y minus 21, is that in slope-intercept form? No. So let's put it in slope-intercept form. I want to get y by itself. So remember, we treat this 7, we call it like a family member. It's the closest thing to it. It's the last one to leave. I need to move this minus 21 to the other side. So I can add 21 to both sides of the equal sign. This leaves me with x plus 21. I can't add those, they're not like terms. Equals 7y. I've almost got y by itself. I need to undo this multiplication by 7. So I divide everything by 7. Whenever I divide one side of the equal sign by 7, I have to divide everything on the other side. So I'm left with y on this side. I'm left with 1x over 7 on this side. I could simplify this 21 divided by 7. That's 3. Now this looks like it's close to in slope-intercept form, but the y's on the other side of the equal sign. Does that matter? Well, yeah, you could write it as this too if you wanted to. These are the same thing. It doesn't matter what's on what side of the equal sign. So if it confuses you that the y's on the right, just flop it over and move this stuff over. Okay? So based on this equation, where's my y-intercept? Plus 3, the number without the variable. That's where I start at on the y-axis. Right? 1, 2, 3, that's going to be right there. My slope now, what number is in front of this x?
1.
A 1. Remember, it's not a 0, it's a 1. So if you want, you can write the 1 right there. So how much am I going to go up? Up 1 over 7. Right? So I'd go up 1 over 7. 1, 2, 3, 4, 5, 6, 7. If I wanted to, I could go down 1 and to the left 7. 1, 1, 2, 3, 4, 5, 6, 7. And there's my line. If it's not in slope-intercept form, get it in slope-intercept form by solving for y. All right.